Dreamspace is a 3-year collaborative project which is part funded by the EU. The funding that we've received has enabled all of the partners to come together, create, research and test new technologies without the pressure of real-world constraints. It's been an excellent opportunity to collaborate closely with our European partners, some of whom we knew and others we formed brand new relationships with.
Dreamspace is pretty much almost looking at the whole end-to-end pipeline for production. We've looked at the pre-production phase, capturing real locations as pretty much low-cost virtual sets.
We have experience with working with artists and performances and installations. We try to see which components could have an impact on film and broadcast.
The concept of virtual production and using real-time technology in the wider scope has been a major research strand at Filmakademie for years. With Dreamspace, we are certainly one huge step ahead in terms of available technology and knowledge of how to combine real and virtual assets live on a set.
We wanted to see whether we can take the tools that we have, which conventionally sit in post-production offline, and use them in a live on-set environment. How do you capture the physical lighting environment so that you can put that into your virtual scenes, so you can seamlessly match the physical space, the physical lighting, with your virtual space that you're rendering.
When we started with this work, we found there's not too much really prior art. So we developed now a technique that is starting with light probes, but going far beyond what you can do with a single light probe. So we capture a number of light probes from different positions, and from this information we're then able to derive very precise models of the actual lights in position. But also, we are capturing the fall-off characteristics of the light. So this is very crucial, because the light might not be that obvious on the first glance, but it makes very subtle differences to the look and feel of the integrated real and virtual components.
One of the things we're interested in Dreamspace is how camera technology is going to change in the future. So what happens when you get to the point that you're recording depth per pixel on set and you have that available to an artist in post-production?
We had to work on having something that works for real, that is reliable, that can be used by operators that are not specialists or scientists. So it has been one big part of the job. And another one has been, so one of the big problems we have today is really about going away from the usage of green screens. So we've been designing a completely new technique that provides in real time a high definition estimation of the real elements in the scene, so you can compose the objects in the eyepiece of the camera in real time.
This is something that artists conventionally have to produce through lengthy rotoscoping. Can we automate that process so that an artist doesn't need to do so much rotoscoping in the future, now that we have cameras that are recording depth from set?
On the second part, we've been working on integrating, so extracting the main core of the tracking technology we have today for being able to provide a really good tracking. So we've been comparing the tracking we've obtained for the final track with state-of-the-art softwares that are available on the market today, and it appears that our technique just saves a lot of time.
We've also looked at that live shoot that you do. How do you get final quality rendering, which may take many hours per frame in post, working in real time on set so you can really understand the lighting? How do you get a live configurable compositing pipeline available to you on set? And how do you connect this with intuitive, easy-to-use tools that let you control this very complex setup and very complex environment, but with a very simple interface that non-technical users can pick up and put down?
The key part of Dreamspace is that we developed a new compiler technique that allows us to implement the rendering algorithm once and then map it to different hardware architectures and get the best possible performance, actually beating the performance of existing systems. We've been working on real-time ray tracing and global illumination for 15 years now, but it's been very difficult and very time-consuming to program the algorithm for each hardware architecture. And with this new compiler technology, we don't have to do that anymore. We have one algorithm and then map it to different hardware architectures.
So Filmakademie is building on-set editing tools. We call them the Virtual Production Editing Tools, VPET. And it's a central production independent software that allows you to connect to your system. Scene is distributed and then you're exposed with a very intuitive interface to do animation, set and light editing live on the virtual set. And those changes that you perform are synchronized across all clients.
We've been responsible in the project for integrating this together as a single live view system, we've called it, for the project. So we have this live view system, it provides live compositing, and it connects to the on-set tools that let you control this complex environment. And it also records the data that then gets delivered to post-production. So any changes in the set layout that you do, the animation that you author, the lighting control, and actually the parameters for your composite, the key, the grade, the depth of field effect, we can record those and make them available afterwards for post-production.
The technologies developed actually have changed throughout the last 3 years. The entire approach of how Stargate looks at new technologies. For example, the real-time pre-visualization on set, which includes the 3D rendering, but also the compositing and the real-time camera tracking, among other things, is something that is very essential to the work. And what we call the virtual production is something that requires those tools. The second phase, we were also focusing on a live playback environment, so that the virtual production sets could be playbacked in an immersive and holographic way for the director to navigate into the environment and to be able to see that environment in different ways. We tried to get high-quality broadcast film techniques, for instance a 360 and a panoramic backplates. What could they do for immersive installations, artistic installations?
We've been thinking, can we stage virtual production itself? So as art companies, so we made 2 staged theater productions, 2 theatrical productions, whereby actors and avatars were all together on set, where you had a blend of the real and the virtual in real time. Now we have a very long time experience using head-mounted displays in omnidirectional environments. And for this research, we in fact wanted to get rid of the head-mounted displays. So can we project a world around you which adapts to you as you move through that world? Upon the stage, everything is real time. So that is an important and a useful, so in that sense it was very useful to use that element of live performances for testing this principle of collaboration, collaborative virtual production.
We chose Battleground as a test for the Dreamspace materials because it seemed that the Dreamspace tool set was perfect for a virtual reality show, which has to be real time. We kept saying, where's the robot? And without this technology, we would not be able to see, to line up shots. When people can see something on screen with virtual and real combined and photographic, all these crazy things that you put into augmented reality, now you can make a movie as if you were in reality, but you're actually in virtual reality or augmented reality. And that's fantastic.
We certainly have much better tools now than we did when we started the project 3 years ago.
The collaborative workflow within Dreamspace among all of the partners was one of the best experiences that we've had in the 3 years of the development.
Any visual art that includes real and virtual components will benefit from these techniques.
It's been a great project being able to do that.